Okay, in this problem I'm going to show you how to calculate heats of formation. This is problem 13 on your yellow sheet. So you're going to be given a equation like we are here, and then you will be given your heats of formation table with all the numbers. And you start looking up each of the formulas on that table. So we first look up NO2, and you find that its heat of formation is 33.9, and that's units kilojoules per mole. And then you're going to take this number in front, the 3, and multiply it by that. And that gives you the heat of formation that we're going to then use. That becomes 101.7 kilojoules. You drop the moles at this point. Okay, now we're going to look for water, and make sure you find liquid water. That's the one we have in this problem. On the heats of formation table, that's negative 285.8. and that's kilojoules per mole. Then you multiply it by 1 because there's no coefficient, so it's still 285.8. That's kilojoules now. These are our two reactants, and so we're going to combine those to make our HR, heat of reactants. And that number is negative 184.10 kilojoules. Okay, now for the products. Find HNO3 on the sheet, and it's negative 173.2 kilojoules per mole. And then multiply it by 2 because that's this coefficient. That gives us negative 346.4 kilojoules. Then find NO on your table, and it's 90.4. There's no coefficient, and so you multiply it by 1, so 90.4. And then to get our HP, you divide these, you add them together. So that gives us our HP. And in this particular problem, that gives us negative 256.0 kilojoules. The last step is to use the delta H formula, and that delta H formula says heat of products, so in this case that's negative 256.0, and you want to subtract that from your heat of reactants. If your heat of reactants is negative, then put parentheses around it like I'm doing, and it's a negative, which is a positive. Your heat of reactants is not always negative, by the way. It can be positive or negative, so be careful there. And then when we do this, we get negative 71.9 kilojoules. That's our final answer. This is exothermic. And finally, the very last thing is write the heat term in the equation. So since this is negative, we're going to enter it into the right side of the equation. So you write your reactants, and then your products, and then you simply add in this number at the very end, add it in positive 71.9 kilojoules, and you're done.